Live.
All right, we're all live. Okay. All right. Try again. Hi, I'm Alex Williams of the New Stack. We're here for our weekly show, the New Stack Analysts podcast. I'm here with my co-host, Donnie Berkholz of RedMonk. Hey, Donnie.
How you doing?
Great. And Michael Coté of 451 Research.
Hello, everybody.
Hello, hello. And Alexis, can you please introduce yourself?
Hi, everyone. My name is Alexis Lê-Quôc. I'm CTO and co-founder of Datadog. We are a monitoring company.
Excellent. And so to get started today, I thought we might just have you, Alexi, tell us a little bit about Datadog, and then perhaps you can explain a bit about this checklist for AWS services that you are prepared for us to discuss today.
Yeah, sure thing. So Datadog is a company we started about 4.5 years ago. Now we started in monitoring, which I think of all of all areas of the industry is one where you'd expect to be it's a pretty tough market in general. And I think what we're seeing this time around is that essentially because of all the move to the cloud, where infrastructures change a lot, monitoring has to deal with that, and that's kind of we built essentially the company around that model. We built a monitoring product that would kind of understand that the traditional infrastructures very static are gone, and then now that monitoring would have to deal with servers coming and disappearing, changing roles all the time, and that would be sort of a normal way as opposed to signaling something abnormal. So we obviously, a lot of our customers are on AWS. We also have other customers some customers on other clouds, but I figured because we basically look at all the AWS services, we think about how do we monitor them on a day-to-day basis, then it makes sense to share a little bit of so this checklist, which tries to present how we understand the AWS ecosystem, that their service portfolio, and how it affects, I think, from an operations standpoint, how you can understand it, how you can kind of look at new services being announced and, try to make sense of it and see how it's going to, whether it's helpful for your, day-to-day. So, that's initially I thought that'd be a useful thing, for us to share with the audience.
Great. So can you give us some idea of the scope of services that you're monitoring? And I'm just wondering how you even got that list together and and actually kind of keep it live and keep it fresh.
Yeah, sure thing. So the kind of stuff we're monitoring is essentially anything on the infrastructure side. So it could be machines, it could be hypervisors, it could be databases, it could be app servers. It could also be sort of custom apps that we can monitor via StatsD. So we focus a lot on open source building blocks because this is a new stack, right? So it's not we're not big in the old sort of Oracle world, and we're much more around NoSQL databases, obviously public clouds, private clouds, PaaS, and the way we drive the level of integration that we support for monitoring is really mostly through what's being used, what people are asking for. So I think very early on we had Cassandra. That's maybe 3.5 years ago. Cassandra support, Mongo, React, and so on. So all the new tools, the new components that are being used in distributed architectures, we want to support them. Sometimes we build support for them in Datadog. Sometimes it's our customers that build support. So we also try to make as much as possible open source because for us it's really a way to make sure that being a monitoring company, you can audit the code and what's happening when you install your stuff, our stuff, on your infrastructure. And B, it's a great way to really have as much coverage as possible.
Can you then show us the document and then we can, start talking through it?
Yep.
And so you guys, Donnie and Michael, you guys look at monitoring services, in the market, and how, what are some of your observations about AWS in particular? Is that where most of the action is right now?
You mean as far as where people need to monitor things? Is that what you're thinking of?
Yeah, for distributed infrastructure, is it still primarily, with this new generation of monitoring services that we're starting to see?
Yeah, I mean, it's a lot of places, and, depending on who you listen to, they've got different opinions of where all the cloud footprint is. But I think, the point that, is it Alexis? I'm trying to say that right.
Yep.
Okay. The point you made about, the new generation of software for the new generation of the way people work with operating systems and work with systems is very accurate, and I've seen that happen with configuration management before it. You start out with CF Engine, which is actually like 23 years old or something like that now. It came out in 1991. And then, later on we saw Puppet and Chef, and more recently we've seen Ansible install coming out. And every time it seemed to be, responding to changes in the way people want to work with hardware. The beginnings of cloud, and then now we've been around cloud for a while. We're trying to figure out, how do we deal with transients? How do we deal with scalability? We need something that's very fast and performant and that can scale in its own right. And, it's the same kind of thing that's happening with monitoring. So I definitely agree with that. And with, the kinds of problems Datadog is trying to solve of, one, outsourcing the infrastructure because, frankly, companies don't differentiate on the way they monitor in most cases, unless they're a monitoring company. And then secondly, on, the traditional approach using, well, depending on what traditional means, either it's the old school Big Four or it's not AWS, just really doesn't cope well with transient servers at all. And so I'm definitely seeing, that change happening to people moving to newer monitoring solutions, whether it's Datadog or whether it's, some open source options like Sensu, for example.
Okay. Donnie, your audio is a little choppy, but why don't we get right into the checklist, and then we can start, thinking of some questions to start asking about, from Alexi. And Alexi, could you again just give kind of like what was your thinking behind putting this, this checklist together? Because when we were first talking, you were talking, you had, especially Lambda reminded you of, conversations you had with database analysts, in prior, in prior work that you've done.
So the genesis of this checklist is really it's really, I think, about how we look at where AWS is coming out and how we see it fit or not fit in, for instance, in our internal infrastructure and architecture, but also in our customers or people we know in the industry in their architecture. So obviously we have an emphasis on monitoring because that's what we do, but even as a sort of an end user of AWS services, we kind of find ourselves asking the same questions over and over for each new service that's coming out. So what I wanted to capture is trying to have some kind of recipe that is really helping to frame how we think about the service, an AWS service, kind of where it fits in the stack, how you can address it, whether it's really low level or high level or kind of somewhere in the middle, how you're going to integrate it in your sort of day-to-day life cycle. So when you're doing release, what's the surface contact there? What's the interface? How does authorization work, and so on. So really is and then with that checklist is look at some new services that were announced recently. So I picked two as examples, Lambda and so they're here. And Aurora is, well, what's what does it tell us? So the goal of the checklist is essentially for you to end up with a sort of a shortcut of sort of mental shortcuts where you can say, yes, okay, Lambda, I know what it is, I know what it compares to, I know where it fits in the stack in terms of it's really low level or really high level. I know how to deploy it. I know that kind of stuff. What happens when it fails? So really having some a way to build these shortcuts, then to be able to figure out quickly what does this make sense in my architecture or not.
All right, Michael, what's your kind of first few thoughts on this list?
Yeah, that seems exciting. I mean, as one always does, I'm trying to think of the things that are missing from it. But it is like if you were building an application, especially for deployment, like on a newfangled cloud context, right? Like I think a lot of these things are important things to look over. And I like that there's identity on there, right? Because that's the part that's often left out, and not only left out, but I have a friend who's a product manager often at companies he works at for identity management, and he's always commenting on those damn developers keep re-implementing it every time, right? Like it's an area that people don't pay attention to, and also instead of reusing services that are available, they're often re-implementing users and permissions and things like that. So, it's nice to see something like that brought up to that prominence. But definitely, like, I think having a checklist to go over things to monitor for is handy. And then the other part that's interesting and kind of comments on stuff you see going on the application development layer is, what was the first one? Sort of like the mode of operating or something, right? Like, are you using like a typical LAMP stack sort of thing, some sort of like wacky, what do they call it, 12-factor thing, or is it even crazier with your Lambda style of doing things? And there's almost sort of acknowledging and thinking ahead about the styles of application development you're doing definitely will drive a fair amount of the monitoring needs that you have. So sure, I mean that seems like a good list to start with, especially when considering the ecosystem of tools around your application. I mean, I'll just reference one last thing before I wrap up. I saw a funny tweet this morning from James Ward, who works at Salesforce as an evangelist, and he was at Adobe a long time ago, and then that small company I forget the name of, but he was saying, like, he was kind of joking, probably only like a third joking, that 10% of learning a programming language is the language, and the other 90% are all the tools and supporting things you need around it. Mm-hmm. Which I think kind of this list points to that, is like, good job getting the application up. Now you need to do a whole bunch of other stuff, which this is a good list to launch you on that.
Donnie, does this point to that?
Yeah, I mean, I definitely agree with a lot of what Coté was saying. It's one of those things where if you go back and look at like the way people's brains actually work, they need to have a framework of existing things they understand to fit the new things into. Otherwise, they have no idea, what the use cases are, where do you put them in. Like, especially with something like Lambda, for example, it's like, well, what even is that, and how would I use it? I think that's the biggest problem people are having with these things, is they don't get the mental model well enough to understand, like, where would I substitute this in for something else. And so, having a clear set of criteria or sort of a grid like that helps people understand, the things that I would probably add to this that would be valuable to would be like a set of use cases, just to really make it crystal clear, like, okay, here's the service, here's how you do it, and then here's when you would do it, or here's why you would do it. And then maybe, one thing that is a big problem, especially with public cloud, is data gravity, right? You get your stuff in, and it grows and grows and grows, and it sucks more and more data in, and you can't do anything outside of that cloud anymore, because you can't afford to export all the data, either price-wise or speed-wise. If you've got terabytes of data and you're trying to suck it out over Amazon's pipe, it takes a while, and it's incredibly expensive. And so, understanding what the process is like to leave a piece of software, if you decide to leave and go do something else, is another important step to my mind, and one that gets left out of almost everybody's perspectives, not just the people making grids, but also the people building the software, where they're trying to think, they think through what the design experience is for every step of the way, what's the UX like, but they never stop to think, well, what is it like if we shut down the service for our users? What is it like if they want to leave for something else? Because, at least in my experience, people are a lot willing to sign up for something and try it out, the less they have to commit initially. And when you have to commit to throwing in a ton of data and it getting really hard to get out, it takes a while to build up to that kind of level.
So Alexi, what were some of the use cases that you were thinking about when you're putting this together?
So, and so the way I wanted to frame it is, and the first two questions I think is how the ones that lead to the use cases. I think the rest is really how do we then support these use cases. But the first one that I always have is like, is there an equivalent already out there? So it could be, you could say, well, EC2, it's virtual, a virtual environment. I mean, yes, you sort of abstract away the data center and so on, but that's kind of VMware would be the when it was announced, people were starting to think about, well, this VMware, or Zen, of course, in the open source equivalent. For something like Lambda, it's a little bit more up until I think recently was a little bit more esoteric. So I think the open source equivalent, and I picked a few. So Storm, like so subset of Storm and S4 or Samza. So process things in stream in a fairly stateless fashion. So the example that's touted and that's used as a sort of hello world is, you want to do some image encoding where you're not sharing state with anything else. You're just getting all the data. You apply some processing. You put it back somewhere, and then that's it. You've done. The Lambda sort of computation disappears. So it's really I mean, the case of Lambda, I see a lot around processing, but it's processing of a stream processing of a certain kind when you really can have these computations be fairly self-contained, so image encoding or anything around where you're going to crunch something. You're giving a piece of data, you're going to crunch something, and then spit out a result and be done. It's not really. I don't see it really as a substitution for the sort of map reduce aspect of things, or if it is, it's really only in the map part. So. Great to crunch a bunch of data, but then when you want to aggregate results, not so good. I mean, I'm sure you can, and people will get really creative because, you can basically run any kind of node code, but I think from a latency perspective and data gravity, a Lambda computation can only do so much. So for me, the equivalent was a subset of Storm, for instance, in as much as you're not yet defining really complex topologies where just with Lambda you can do this part, and then depending on the result, that computation, and then depending on the result, that computation. It's a lot more like a building block. So just here's the source of data on each bit that flows through that source of data. Apply this essentially this JavaScript function. In the case of the other sort of recent example that I picked was Aurora. That's a kind of put us from an open source perspective. Is I thought of, well, this is kind of MySQL on top of a smart file system like ZFS, where you can have sort of elegant replication and plus a few things around, obviously, in the case of Aurora, quorum reads and quorum writes. But that's kind of essentially how I thought of it. Is this is MySQL without most of the operational problems. So you can get extra speed because you have sort of built-in replication, built-in read replication, and you can have also sort of a, because of the smart layer under it, you have a MySQL that kind of never crashes, or so it seems. But that's kind of how I approached it initially. So I think where it fits now in terms of use cases, well, Aura, it's kind of easy. All right, you have MySQL, you have throughput issues or reliability issues. You swap out Aurora, and that makes sense. It's in the case of Lambda, it's a little bit more obviously open-ended. It could fit where you run an app on Node, and the backend for Node is S3, for instance. It's not some kind of transactional or database. Then technically you could replace your set of Node servers with a bunch of Lambda functions, and that's just basically gonna respond to requests and then interact with some backend. But I think in the case of Lambda, it's a little bit more. It's a little bit more of a primitive building block as opposed to something like or one service that he mentioned because of the sort of the relative lack of information about it. The container service that they announced at reInvent. That's more like the equivalent sort of open source equivalent is some kind of Kubernetes plus Docker, obviously, with again some some a little bit more advanced smarts around orchestration.
Mm-hmm. So, Michael, what is your thoughts on on these use cases? Do you have anything?
Well, I actually to answer your question with like pushing another question on the stack, like looking up over these use cases, it's an interesting way of approaching a question I always have. So back when as I like to joke, I did real work. I programmed instead of just talking about people programming. I worked at BMC on like what was basically their patrol product line, monitoring and doing all of this stuff. And back then there was also like Wiley and like there's all these tools that basically do monitoring, if you will. And an interesting phenomena is kind of playing out here in front of us, where it's like, so what are the technological underpinnings of how applications are developed, the use cases that are driving applications and the technologies that are using, such that companies like Datadog can come to exist? Like why don't the patrols and the or performance manager, as they call it, and the Wileys or whatever they call it now, sort of just work with that stuff? Right?
Yeah.
And it's an interesting phenomena in the same way that there was a point in time, I guess maybe in the late 80s and early 90s, where Patrol was the crazy new relic in Datadog that was like doing all these wacky new things that whatever, I don't know, Candle maybe, whatever old mainframe and mini computer stuff that was doing monitoring didn't work to monitor distributed systems, or as Steve Jobs used to call them, open systems. And then this new realm of monitoring came about that Datadog's part of, that's sort of monitoring cloud applications, and for some reason the instinct of users isn't to go install Performance Manager. And it's going over these use cases kind of points at one answer to that, is like, well, the entire stack is different. So those old tools maybe don't work as well. But this is a bit of a softball question, but I'm curious, like when you guys at Datadog look at it, like how, I mean, do you even compete against the old pre-cloud monitoring tools, or is that not even in the same area as something that you guys come up against?
So I think the short answer to why I think we came to exist is I've been thinking about that a lot over the past year, and I think it can be ascribed to basically the fact that pre-cloud, the de facto, so the most useful, I'd say, abstraction, or one of the most useful abstractions in terms of monitoring was the machine, the host. So something that exists kind of all the time, that's will be started once in a while, and then but then is something static that you can rely on, that doesn't change that much, that has a certain identity that's stable over time. And what we've seen is the kind of even something like EC2 that gives you hosts that have some identity that is stable over time. The fact that this whole transience around it makes it that it's just not so useful after all to think about hosts. And something like Lambda is a good example as well. I mean, obviously there's some machine that powers these node processes to process the data. You just don't have access to it, and frankly, you don't care. So I think that's one aspect that I would say.
Right. I mean, to summarize it, and you kind of opened with commenting on that when we started recording, but it seems like there's almost a one possible law or theory of monitoring tools is that, it's going to sound stupid when I state it, it's that it's obvious, but like when the underlying platforms change, you have to rewrite the management tools, right? Yeah. Like it just, there are exceptions to this, but in general, you can't really just simply refactor the management tools to kind of work with when new platforms are introduced. And so that's kind of, maybe if you were to track out the cycles of monitoring, there are different platforms emerge when the architecture of applications being monitored change themselves, and that's what creates the windows of change, if you will.
Donnie, do you agree with that?
Yeah, I mean, in general, it's the same kind of thing I was saying. It happened with configuration management before it, and as Michael has pointed out,
Yeah,
it
exactly.
happened back in the '90s as well. It's certainly the case. Although I think, I'm optimistically hoping we're starting to understand that happens. Although, history has proven that wrong many times. But because it seems like we're starting to turn these things into much more of a platform than they used to be, right? If you look at the empowerment of developers over time, it's getting a lot bigger with things like open source and cloud and whatnot. And so I'm hopeful that the same kind of thing is starting to happen with areas like monitoring, where the architecture changes, but we've managed to abstract the monitoring platform far enough away and make it flexible enough without being overcomplicated with enterprisey goodness, that it can still cope with changes to a fairly large extent in the way we build apps, right? I mean, like one example might be, okay, we're moving from this monolithic application architecture to a more microservice-driven one, as we've done before. But in a lot of cases, we haven't had to switch to entirely new monitoring tools to do so. Right? We've been able to send it to the same tools, but they're flexible enough that you can send different kinds of data sets and monitor them in the same way.
How does the container story change the equation, if at all? I mean, is that going to create, how's that changing your approach, I guess, in particular, Lexi? Is there a shift that you need to think through with, with now kind of the growing popularity of container technology?
I'd say not so much, and that's really to the point Donnie was making just before. I think the one way to look at the way we do monitoring is to think of it as we do it in a more declarative fashion. And by declarative, I mean when you really monitor, you want to know when. So you can express your monitoring concerns as, I want to know when let's say, when the aggregate traffic or aggregate amount of requests for this particular application in this particular region of the world hits a certain threshold, for instance. And so that's how you express it. That's how, as a person, you care about it. Like, you want to know, are we serving traffic in the U.S., for instance, or not? That you have 5 machines to do it, or 100, or 1,000, or half of them are down, or frankly, you don't care. And I think containers are just going to exacerbate that. When people were moving to the cloud, they're trying to have sort of the ground was shifting under their feet, in the sense that machines would sometimes be there, sometimes not be there, and then have to architect around that. With containers, I think it's just the same idea, but just much faster, in the sense that containers are going to be pop up and do their work and disappear at a very high velocity, even compared to starting and stopping EC2 instances. And from a monitoring standpoint, that means expressing monitoring concerns as something as queries, essentially, in a declarative fashion, not in an imperative fashion. Not say, I want this container, that container, and that container to be up and doing stuff. You want to say you really care about the results, not so much about the process. And that's how we've had initially built the service, and we found that it served us well in being able to monitor containers without having to rejigger anything in particular.
With was that someone going to say something?
Oh, no. I was thinking. I like this idea of a transient application. and then therefore you need to, your management tools are relied on to basically, I don't know, is this the right word? Know the epistemology of your application, know like what the actual truth is of it, if you will. Where instead of relying on your infrastructure to sort of know the topology and know the layout of your application, like it's kind of it never fully exists at any given point in time, so you have to rely on your management, as Donnie was talking about, your configuration management and tools like that to kind of track its existence, which which to the rambling question I was talking about earlier would basically confound the previous generation of monitoring tools, which are very Donnie was joking about this other day. They don't use tags; they use taxonomies, right? So there's like an upside-down tree of existence that most previous monitoring tools use, rather than sort of like abstract notions of this application could be here at one moment or not, or whatever. We have no idea. So I don't know. That's some interesting confusion to slather onto this conversation.
Yeah, I was thinking about what you were both talking about, and you know, in terms of dealing with things like the container revolution or evolution, if you will, and you know, how do you do that with monitoring sense? And it's the same kind of transition that's been happening with the move to cloud, right? In that it's one of scale and abstraction, just another time around. And so, you know, with containers, maybe you've got 10 times or 100 times as many containers as you used to have VMs, 10 times as many VMs as you used to have, you know, hardware nodes. It's just the same thing over again, and you just got to make sure that, you know, whatever the monitoring solutions are, they've managed to architect or at least design for enough scale that they don't have to rewrite a whole new competitor to make it happen. Because, I mean, the other challenges are largely, you know, details in nature, right? Like, oh, well, if you're going to monitor a container, well, then it'd be nice if you could actually get some data out in a flexible way to monitor it, right? It'd be great if the networking worked well. It'd be great if, you know, the transport in and out of the container worked, you know, well, and also worked in a securable fashion so that you're not opening up big holes when you do that.
So my question then is, do the monitoring services, will they change much as like new services start to come online, such as from, you know, we have a Lambda now, and Aurora now, and there's going to be kind of any number of others, and increasingly those services are going to be running not just in AWS, but they're going to be running across multiple cloud services and you know, in companies' own data centers.
Yeah, so I think that the nature of the data we're even seeing is changing, and so in the case of there's a couple of changes, change of nature, and then kind of the multi provider or provider, I guess, approach that some people are starting to take. I think makes it so that monitoring is changing. On the one hand, the nature of data. So I think if you look at monitoring sort of pre 2005, so from the mid 90s and even before, the kind of data that were collected where in volume there was a lot of sort of low level stuff like CPU, memory, the classic stuff that you can get easily. That may or may not be actionable, but that's how you drove your infrastructure as you monitor that kind of low-level resource consumption, and that was that. With things like Lambda, to some extent, containers, all the sort of high-level data stores like Kinesis and Dynamo in the AWS world, you start seeing because the machine where the physical machine where it runs is abstracted away a number of times, you don't have access to that anymore. So you end up with the kind of metrics that are exposed in the case of Lambda, for instance, is essentially three things: is how many requests it's doing, what's the latency on each request, or what's the distributional latency, and how many errors you're seeing by amount of time. That's it. And so what that means is the monitoring turns into this part of it, which is still obviously collecting metrics, and sometimes if it's on bare metal, it's low-level metrics. But a lot of it is also around integrating other metric system, and that's something that at Datadog we kind of built from the get-go because when we started, we said, well, there's all these tools that pre-exist. We're not going to try to displace them, reinvent the wheel. We just consume what they're spitting out, and the value that you're looking for is really kind of seeing the big picture. So if you're using Lambda, you will want to have these three metrics: request, latency, errors, but you want to see that in context with other higher level metrics. Maybe it's like business metrics or metrics from other parts of your architecture that are not on AWS. And so that's the first thing, where it's not solely about collecting data at the source. Sometimes it's also aggregating data that's already been sort of rolled up and collected by some other system. And then that's aggregation across different sources. And then to the data gravity, one would say vendor lock-in aspect of running in one cloud versus the other cloud. So we're starting to see more and more people interested in diversifying. And there again, every cloud, every ecosystem is going to come with its own way of measuring things, of monitoring things. And our challenge and what we're what we're building is something that can make sense of everything. And at the end of the day, they still present you with one. I don't like to use single pane of glass because it's somewhat, there's connotation behind it. But basically, you can understand what the hell is going on. Whether your containers happen to run right now on AWS, and tomorrow they'll migrate to another cloud because they happen to be cheaper, and you still need something that gives you the truth of your of your architecture, of your infrastructure.
Any thoughts, guys?
Yeah, I mean, I definitely agree with Alexis that we're seeing a lot of the same kind of polyglot shifts, or polyglot shifts, I should say, right? We saw it with languages, we saw it with databases more recently, and now it's happening with Glue, right? There's this whole conference, GlueCon, that's just about gluing together APIs to build apps, whether it's a website or a mobile app. Most of the ways people are building things these days are pulling together a bunch of external building blocks of generally open ones and gluing them together to get something useful. So we're absolutely seeing quite a bit of that, and the upside is now that we've realized that's the way people are building apps, we're starting to see ways to manage that on top of them, like Terraform from HashiCorp is a great example, right? The same guy who created Vagrant came out with basically a management tool to let you glue together. It doesn't matter whether it's code or an API or whatever, you can define what your logical application looks like across all of that. So we're starting to get to that point, and I have a feeling, we'll see a lot more of that over the next couple of years. There's my Christmas prediction for you.
What are the complexities in gathering that data across those different environments, like you're talking about? Aggregating across those different services and different, on-premise environments.
No, I'd say that the main thing is to get this is not surprising, but to get the data model right from the start. So and I think it was I forget whether it was Donnie or Michael that were mentioning tags, but that's for us. What made this possible essentially is to say that basically every piece of every point that comes to the system can be tagged with anything pretty much. So if you're measuring CPU on a machine in a data center, downtown Austin, for instance, if there's such a thing as a data center downtown Austin. You can tag it with, this is from this machine, it's in Texas, in US, and you can essentially add a bunch of metadata to every single point that comes, so that in the end you can run queries and say, well then, what is the average CPU utilization of all the machines that run in Texas that I have, regardless of which data center they're running. Now, that works for kind of low-level resource consumption, CPU type of metric. That works as well for anything from even a higher level service. Use just the same idea. Instead of being the machine, the data center, the operating system version, it could be the region. In the case of AWS, the region, account, function name. In the case of Lambda, for instance, configuration ID. So it's anything that you find useful to refer to what it is, what your computation is running. So if it's a database, it's going to be the type of database, the instance, the identifier for the database, where it's running, what kind of, maybe what class of what class of instance it's running, or that kind of information, as well as maybe some tags or some metadata that are only make sense to your to your internal organization, maybe some internal application name, or maybe some version number of that application. So the idea is that you want to have a data model that's flexible enough that you basically can adapt to whatever you're collecting. So for us, it's really we can collect anything that it has to be quantitative for the most part. So it has to be measured. It has to be a number. It's tied to a point in time, so it timestamp to it. And then there's a collection of tags that really will depend on where the data is coming from, whether you're enriching them or not. But it's a pretty damn simple data model. And I think if you try the taxonomies from the old days, then you lose the flexibility to adapt to new architectures and to new ways of conceiving application. And yes, it's in some sense easier to navigate in a very specific context. So if you look at your infrastructure from this is the country, this is the data center, this is the rack, this is the machine in the rack. That's it's nice when you want to know what runs in a given rack, but it just, as soon as you're moving away from that data center, just the whole taxonomy stops being useful. So we purposefully shied away from using sort of hierarchies and taxonomies and just have a very flat world of tags.
Michael, I know you got to get going, but any last thoughts on what Alexis is talking about here?
No. I mean, I'll try to painfully summarize what I was talking about earlier, but I think coming up with that model of your application is definitely that's one of the more valuable things in this space that I don't think too much about, but that's kind of obvious from the conversation that we have, and that's that's nice. I think as things get a lot more complicated, or to use the phrase, you have like polyglot programming, right, where you're using many different technologies and languages and services together to make a composited application. Yeah, I mean, having some place that stores that model and knows what the application looks like is one of the more important things you can come up with. So that's interesting, and I think kind of like that and other things pop out from the checklist that's here, right? It's sort of like know the type of application that you're building, so you can know the associated tools that you'll probably want to support it. So that's fun stuff.
Epistemology is a reminder of belief systems, and of belief systems in polyglot languages. I think we're moving into whole new dimensions here.
That's right. Aren't you the one that knows Latin? Someone around here does, and so maybe that'll come in handy.
Maybe someone else out there.
That's right. Well, I'll see everyone next time. It was a pleasure talking with you guys.
Thanks, Michael.
Thank you, Michael.
Cheers.
So I guess one of the questions I have about this is I'm thinking through kind of the use cases that you've presented. I'm thinking of, again, kind of like that larger question again about if we're talking about multiple data centers, multiple cloud services, how does this checklist change?
I don't think it changes that much. I think this is the checklist is really it's definitely provider agnostic. I mean, so the goal of the checklist is for you to have mental shortcuts that then you put these shortcuts in a toolbox, and then you can open the toolbox and say, okay, I need something that's going to do stateless computation. What do I have? What tool do I have? So that's why, granted it's reasonably high level, but I like to think that it can be it's a good framework to decipher kind of like new services being rolled out, and that's you could say, I don't know, for instance, Google Cloud's going to come up with something similar, or people like Join has something similar to Lambda. I mean, it's always there's like similar offerings on the market all the time, and then the checklist is really there to kind of let you cut through try to get to the bone and figure out how is this thing built, how it's going to be useful.
It's all about your model and your methodology.
Yeah.
Really.
Yeah. I guess I would actually disagree with you a little bit on that one, because I think that in a cross-cloud world, the things that become more important are integrations and partnerships, and choosing tools that support your entire infrastructure. Because if you've got Lambda that's only Node and you're writing everything else in Go because you're a trendy San Francisco startup, you might want to rethink whether it's worth it to diversify your tool chain to that extent. And it's not that bad for a couple of languages, a couple of tools. Once you start working your way up to 5 or 10, it suddenly becomes pretty complicated to hire engineers that can manage all of those, or even a majority of them.
Yeah, I mean, that's for sure. I think the case of Lambda is a little bit maybe particular because they chose. I mean, and I can understand why they choose Node, but because this is Node or nothing. And I'll expand, but clearly, I think for me, when I looked at these new services, I sort of come back to what you were saying in terms of data gravity. And another way to look at it is sort of lock-in, and that's one thing that's implicit in the checklist is the higher level the service, the more data. If it's a data service, if it's a high-level data service, it's pretty hard to move away from it. So that's one thing to, I think one criteria we could add to the checklist. Though from sort of cloud providers, it's likely that they all will have. Well, the lock-in is going to be pretty. Pretty high. Clearly in the case of AWS, I think that's the whole business model is predicated around that. So, but in terms of polyglot and in choosing, for sure, if you have 5 things that can do stateless computation on a stream, you should definitely go with what you feel comfortable from a language perspective or from a tooling perspective or something that'll fit your environment. Though, one could argue the opposite, where people get excited about new stuff. Oh well, we use Lambda, so that's an opportunity for me to learn Node. That kind of thing. So, important to keep in mind the ramification of that. But sometimes it's almost like we use this. This is like a hiring tool.
Yeah, no, it's funny you mention that because I actually run into in the environments you would never expect it. Like for example, banks building sort of systems of engagement style apps. A lot of times, the only way they can manage to hire good engineers is by letting them play around with technology and whatever they feel like. So like, oh yeah, you want to build something with Node and Backbone? That sounds awesome. Have fun with that. Because that way you'll continue learning and you'll stay here instead of going to, a startup that is doing something cool but in a very boring way.
I guess my question, I guess one of my last questions comes back to Datadog, and I was actually just looking at Lean Stack, which is now StackShare. Do you guys use that service? Do you guys check it out?
Yeah.
Donnie, do you ever go to Lean Stack? Have you seen that? It's pretty cool. It shows, and it gives an overview, but also of a developer tool company like Datadog, but it also shows the integrations that you guys have, and I can show it maybe here. Let me see here. There it is. Okay. So what it shows is all these different services that you're integrating with, which I find really interesting. I'm wondering how you're thinking about your own stack as these services become far more sophisticated, like that you're seeing across AWS, and kind of extending beyond that.
Right, that's a great question. So from the moment we started, and because we wanted to stay pretty agnostic. So from the moment we started, we said we'll basically use the lowest common denominator from a platform perspective. So we'll use machines. We'll use as few high-level services as possible. Not because we don't like those. They would arguably make our lives easier. at least in some respect. But just we have to, it's AWS. We're not married to AWS. We need to be able to sort of propagate beyond that without having to re-architect the product re-architect the product in a really deep fashion. So we've obviously always looked at new services coming out, but we've always evaluated very carefully whether we could, to Donnie's point, what does that mean if we start using, for instance, we use Kafka internally. What would that mean if we start using Kinesis instead of Kafka? And the answer is, well, then that means we have to, either Kinesis has an interface that's high level enough that we could substitute it with something else, or if it doesn't, then we just we want to think twice about using it. On the other sort of end of the spectrum, there's tools like services like S3, where frankly, it's the interface is so standardized and so generic that yes, there's data gravity in S3, but one way or the other, you're going to have to pay that to pay that price of having some kind of interface. And the interface is generic and simple enough that in that case we don't mind using having some kind of lock-in. And to the point where when we run in with other providers, we can still go and hit S3 as one of our backends, and it's not, yes, the data is in S3, and we're accessing it from non-AWS LAN, but that's okay. We made our peace with that.
Well, that's really an interesting discussion. I could go on quite a bit here, but I think this is a good place to stop. Donnie, do you have any last thoughts or perspectives?
I mean, my perspective, I guess I'm eternally, bipolar, and that I'm optimistic and pessimistic at the same time about the way tech is going to go. I'm so hopeful that this time around, hey, we've figured out monitoring, we've figured out configuration management, we've got the problem solved, we're a general platform now, we can adapt. And yet, every time around, it seems like something surprises us, and so we have to rebuild everything, right? Like next time around, maybe it'll be functional programming, right? Because as you get more and more parallelized processors, suddenly you've got to deal with things in a functional sense. You don't want to do declarative anymore, even. So, I'm kind of wondering what's going to happen when people start programming that way, or what's going to happen when, memristors, whatever the word is, come out finally after, 5 years of HP talking about it. It's always curious, what are the next revolutions going to be? Because typically they're not ones we were able to foresee and architect for, right? Like, we're always architecting for the last battles, right? We're not architecting for the next ones. It's a lot like the way, the countries structure armies. And so it's going to be really interesting to see, what's the next big thing, and have we managed to, not predict it, but allow for it?
Yeah, it's a topic for another show, because one of the conversations I had recently was that I think about is just the different ways that we approach programming, for example, here in the Western world, United States in particular, and how that compares, for example, in China, and how the approaches are different, and how in here, the person I was talking to was talking about here like it's a very kind of an individual exercise, and people have their own very opinionated viewpoints on application development, which doesn't mean that developers in China don't, but there's a different approach, as I understand it. If I'm building, if I'm like a table maker, I am, the apps are uniform, right? There's no, an app will be built the same way, because primarily they are being built on, on a very few number of actual platforms there, and so kind of changes the complexity on one side. So then you really are trying to show the differentiation in the table, or or the piece of furniture, more so than in the app itself. The apps don't change quite a bit. And I don't know if that changes the complexity underneath the development itself or not, but it's kind of a topic of interest for me. Maybe we can talk about it some more another time. But on that note, I would just like to thank you, Alexi. Thank you very much for participating in the show today.
Thank you for having me.
Yes, and best of luck to a Datadog, and we look forward to keeping in touch on the evolution of your own technology stack and how that's adapting to these, to AWS's new services and the ways that corporations are managing their own environments and across not just AWS and Google but their own. And Donnie, thank you very much for joining us again today. The audio did end up working out, so I think we may have solved one problem here. And
pleasure.
yeah, and to Mr. Coté, it's always a pleasure to have you guys all with us. And Michael, if you're listening, which I don't think you are, but thank you very much. But thank you guys. We'll talk real soon, and and if I don't talk to you, either of you, have a great holiday and a happy New Year.
Yeah, have a great holidays too.
Thanks.